Hi guys, today we are going to talk about factoring with imaginary and irrational numbers. So in our last unit 1A, we had a couple of problems that we stopped factoring because we said we couldn't factor them anymore. Or we had some problems that we said not factorable. What we really meant is that we couldn't factor those problems anymore, or they were not factorable with real rational numbers. Okay, they were not factorable with integers. When we factored up to this point, we have only factored with integers. So today we're going to take a look at how we can factor with imaginary numbers and how we can factor with irrational numbers. I want to start with a problem that we actually can factor based on what we know already. Okay, so if I want to solve this by factoring, which is what we've been working on, right? Solving and factoring the method we've used to do that, I could factor this as a difference of squares. I've got an even degree binomial, two terms, subtraction, both of these are perfect squares, so I could factor this with that difference of squares strategy. So I want to know, what did I square to get x squared? Well, that would have been x. And what did I square to get 4? Well, that would be 2. So I could factor this as x plus 2 times x minus 2. And then if we're solving here, I would set each factor equal to 0 and solve for x. So I would get x to be -2 and x to be +2. Since we've been talking about solving, we'll go all the way to the solutions on this intro problem. But the big idea here is that difference of squares pattern to be able to get that factored form. So what we're going to look at today is how to be able to continue to use this difference of squares pattern, even if I have something that's not a difference, so not subtraction, or not perfect squares. That's what we're going to look at for today. So for our first example, we want to factor this expression. I'm going to start factoring the way I would factor any other problem, which is look for a GCF, look for a greatest common factor. I have a GCF here of 3, so I'm going to go ahead and pull that out. So that would leave me with x squared plus 4. Now, x squared plus 4 is a little different than x squared minus 4 because here I had a difference, I was subtracting, and here I have a sum, I'm adding. Now, to be able to factor x squared plus 4, I'm going to use that same difference of squares pattern, but I'm going to have to make a modification. Okay, so I'm going to start the same way. I'm going to ask, what did I square to get each of these? So to get x squared, I would square x. To get 4, I would square 2. Now, if I just did x plus 2 times x minus 2, like we did up here, when I distribute back, I would get x squared minus 2x plus 2x minus 4. When I combine my like terms, my x's cancel each other out, and I would get x squared minus 4. So I can't factor it exactly the same way because I won't get x squared plus 4. Now, if I tried x plus 2 times x plus 2, maybe since it's plus, I want two positives. Let's give that a shot. That would give me x squared plus 2x plus 2x plus 4. Now, in this case, I get plus 4, but my middle terms here, my x terms, don't cancel. They don't reduce out to 0 the way they did before. So I don't get the same thing again. I get a 4x in the middle, and I don't want that 4x. So my solution, my sort of workaround here, is that I'm not going to use real numbers when I factor. I'm going to use imaginary numbers. Since I'm factoring a sum of squares, what I want to use is x and 2i. So x plus 2i and x minus 2i is my factored form here. And I'm showing you why we want the i's. So let's take a look at what happens when we distribute. So if I take I'll write it over here, x plus 2i and x minus 2i. If I take my factors and distribute, I get x squared minus 2ix plus 2ix minus 4i squared. Because I have opposite signs in my factors, my ix terms, -2ix and +2ix, those will cancel out. So I have to have those opposite signs in my factors to get the x terms to cancel out. But if I use opposite signs, that means I would get -4. Now, because I used 2i instead of just 2, I get -4i squared. Here's the tricky part. Remember that I squared is -1. So what I have here is -4 times -1, which is +4. So I get x squared plus 4. Okay, so that's why I want the i's there. I need opposite signs so my x terms cancel out, and I need the i's so that I can flip the sign from minus, because of the opposite signs here, to a plus when I multiply by that -1. So here's my factored form. So here's what we can take away from this. I can use that difference of squares pattern, but I need the imaginary number for that second term when I'm adding instead of subtracting. So when we have a sum of squares, use I. So if I've got a squared plus b squared, my factored form would be a plus bi times a minus bi. So whatever I squared to get the first thing, and then whatever I squared to get the second thing, I as an imaginary number. Now let's take a look at an example where I have a difference, but I don't have perfect squares. So if we take a look at example 2, I've got x squared minus 7. So I've got two terms, even degree binomial, subtraction, difference of squares is what I want to think about here. So I want to know, what did I square to get the first term? Well, that would be x. And then I'm going to ask, what did I square to get the second term? Well, what would I square to get 7? That's a tricky question because 7 doesn't have a nice square root. That's really what I'm asking here. When I asked, what did I square to get 4? I was asking, what's the square root of 4? Same idea up here. What's this? Or if I asked you to factor x squared minus 9, we would square x and we would square 3 because 3 is the square root of 9. Okay. 7 doesn't have a nice square root. So here's my sort of trick for this one. Instead of trying to figure out some approximation here, let's just use the square root of 7. If I square the square root of 7, the square and the square root cancel each other out. They undo each other, and I'm left with 7. So that's what I want to use here. That's my trick here. I'm going to use that same difference of squares pattern. So this would be x plus the root of 7 times x minus the root of 7. Since it was a difference, I don't need any imaginaries. The only trick I need here are those roots. And now let's look at what happens when we distribute. So I can always check my factoring with distributing. And let's multiply these out. So I would get x squared minus root 7x plus root 7x minus root 7 squared, right? Root 7 times root 7 would be root 7 squared. In the middle, my x terms are minus root 7 and plus root 7. So again, those would cancel each other out. And then here at the end, I've got root 7 that I'm squaring. When I square a square root, I'm left with just what was underneath the root to begin with. So I would get x squared minus 7. Okay, so when we have a number that's not a perfect square, we can use a square root. So if I've got a squared plus, we'll say some number c here, I can factor that as a plus the square root of c and a minus the square root of c. So if this guy isn't a perfect square, I can't write it as something squared like we put up here, then I just use its square root to factor. So I can factor using irrational numbers, numbers that don't have nice square roots, that if I type this into my calculator, I get a non-repeating, non-terminating decimal. So now let's look at an example where we're going to do both of those things. Factor the expression x squared plus 5. So I want you to notice that we have a sum here. That means I'm going to need to use I. And I want you to notice that 5 is not a perfect square. So I can still ask myself, what did I square to get x squared? That would be x. If I asked, what did I square to get 5? You could tell me square root of 5. And since it's a sum, you're going to tell me I square root of 5. So we're using both of those tricks here. So this would give me x plus I root 5 and x minus I root 5. That would be our factored form. I have a couple more I'd like you to try for me. Give those a try. If you're not quite done yet, go ahead and pause the video and then unpause when you're ready. But let's take a look at these. What would I square to get x? Well, x. Or what would I square to get x squared? X. What would I square to get 25? 5. This is a perfect square. It has a nice square root. But since I've got a sum here, I need to use an I. So my factored form here would become x plus 5i times x minus 5i. And then for part B, what would I square to get x squared? X. What would I square to get 6? Well, 6 is not a perfect square, so we'll use its square root. So our factored form would be x plus root 6 times x minus root 6. And then let's try one more example. Let's try x squared plus 11. How would I factor x squared plus 11? So to factor this, I'm going to start by asking, what would I square to get x squared? That's x. And now what would I square to get 11? Well, it doesn't have a nice square root, so I would just use square root of 11. And then since it's a sum, I need to use I. So my factored form would be x plus I root 11 and x minus I root 11. And those are my factored forms where my factors use imaginary and irrational numbers. I would keep your notes handy. You may need them for class on Monday.